Hello. Today we are going to be looking at writing some more proofs. This time we're just going to add on using those symmetric, transitive, and property of congruence with angles and line segments that we talked about last time. So just like before, I'm going to have statements and reasons, some of them filled in, some of them not filled in, and I'll give you a bank of reasons and statements you can use to back up what's going on in the proof. So we just need to fill in all the missing spaces here. So let's get started. They've given us that segment LM is congruent to segment NP. Since that is information that they have just given to us outright, we say that the reason here is given. Nothing fancy there. Something they've straight up told you is just given. Now, definition of congruent segments. How can we use that to come up with another statement? Definition of congruent segments says that if LM is congruent to NP, we can say that the length of LM, which just looks like LM without the line segment symbol over it, equals the length of NP. So here we've used the definition of congruent segments a little bit backwards. So I've used given, I've used LM equals NP. The next reason they said we're using here is the symmetric property of equality. So the symmetric property of equality says I can take the two sides of an equation and reverse what's on each side, and my statement is going to remain the same and stay true. So if I have LM equals NP, I can equivalently say that NP equals LM. All I did was switch what was on either side of the equal sign. Now we go back and it says segment NP is congruent to segment LM. So that looks like basically the opposite order of what we did in 1 and 2. Since we know that the lengths are equal, we can say that the segments are congruent. So we are once again using the same definition of congruent segments, just kind of in the reverse order that we did before. Excuse my handwriting, it is not the prettiest today. So definition of congruent segments is our last reason. That might have felt like you were talking in circles, which sometimes with proofs you're going to feel like you're talking in circles, like you're going crazy. But when we are dealing with proofs and working mathematically, we have to be very methodical and do one step at a time without jumping to conclusions. So it might seem like things are redundant, but we are taking slightly small steps to get from the beginning to the end. Let's try one more. This time, they give us this picture with this line segment AB, M is the midpoint. They straight up tell us that M is the midpoint. So we can, what has to go here in blank 1 is our given information, which is this right here. M is the midpoint of segment AB. The given, whenever it says given, it's just what they've directly told you. From here, we are going to fill in the rest of the statements and reasons based off of the information that we are given. So they're saying the second reason that we are dealing with here is the definition of midpoint. The definition of midpoint says, okay, M is my midpoint. That means that segment AM is congruent to segment AB, which we see right here. So we used our definition of midpoint to say that the first half is congruent to the second half. Now, this looks kind of familiar with what we did in the last problem. Since the segments are congruent, we can say that their lengths are equal. And we did that using the definition of congruent segments. Done. Okay. Now the next one is talking about the segment addition postulate. The segment addition postulate says that this piece plus this piece equals the whole thing. And so how do we write that as an equation? We say that AM plus MB equals AB. Now to get to our next step, it looks a little different. We have substituted or replaced this MB with an AM. And we are able to substitute that because of what we see in step 3. Since we are substituting one thing for another, we used our substitution property of equality to say that AM plus AM I'm just going to abbreviate their substitution property of equality. We use that substitution to say that AM plus AM equals AB instead of AM plus MB equals AB. This next step, I will tell you, is kind of weird, so just trust me on it. We can then add these two together. So you might think, oh, I'm using my addition property. But the addition property only works when you're adding the same thing to both sides. So I'm going to kind of do something here. So AM, oops, I did not mean to write that equal sign. Let's try that again. AM plus AM equals 2AM. Or you can think 1AM plus 1AM equals 2AM. If you undistribute those ones, or that 2, depending which side, the equal side you're looking at, you can think of it as being kind of a backwards distributive property. Very weird, weird step there. But it lets us get to our last point, which is what we are trying to prove, which is what we've been trying to do all along, so that's good. The last thing that we are saying here is that AM equals 1/2 AB. So how did I get from 6 to 7? Well, what I did was I no longer have a 2 in front. That means I divided both sides by 2. I'm going to write down here AB over 2 is the same as 1/2 AB. It's just a different way of writing it. So we don't usually write those steps in between. So I'm going to erase that a little bit there. We don't usually write those when we're writing a proof. We just write the results. So what I did there was I divided both sides by 2. So I used my division property of equality. Again, excuse my handwriting. So that is it for our proofs for today. So on your homeworks, it'll be very similar. I will give you a partially filled out proof and some statements and reasons in a bank. You just need to put the right things in the right spot. That is it. Hopefully now you're feeling a little bit more comfortable with proofs. Have a great day.